Okay, today we're working with the College Algebra Review. I have here Marianne with me. We're going to work on this together. Okay, the first one, it says graph each equation and state the domain and range of each equation. Domain is your x, range is your y. And they want us to kind of use these points as a guide. We're still going to have to do the whole equation. That means the full set. So you can use your table and kind of substitute those values, at least for now. -1, 0, 1, and 2. And you're going to use the expression 3x squared minus 6. So I like to use a template to kind of put everything and to save some time. Okay, and then find your y value that goes with it. So the key is the parentheses. Okay, so the first one we get is a -3. This is going to be a -6. So -3, and then blah, 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 a 6. Okay. Once we have that, we're going to put these in here. So we're going to plot them. 0, 1, 2, 3, 4, 5, 6. This way. And then 2, 3, 4, 5, 6. Okay, so then, yes, we do have only these points, but because they want us to put the equation, we're going to continue that. So the domain is going to be from left to right. So we go from the left to the right.
Okay.
It's an arrow, and then you hit an arrow. So it's from -infinity to +infinity. If you notice it from left to right. So you can put that or all row numbers. So you do have that option. Okay, the range just goes from the bottom up. What's the lowest?
The lowest?
The lowest y value.
I don't think I even plotted it. I have my -6.
There you go.
Right
So what
here.
is that? That's right.
-6.
Good. -6. So -6 is the lowest, and that one is going to be a closed circle, and then it goes all the way up. And what do we hit?
+infinity.
So we're going to go up +infinity. So you have this option, or you still use your values. All these are y values that are greater than or equal to a -6.
Okay.
And then do the same thing to the other one. We're going to create a table using those same values just as a guide, using the same equation. Well, I'm sorry, a different expression. What I meant was the same thing. Okay, and now we're going to solve it. So when -1 gets in place, we get a 1, a 0, that's a -1. When we put a 1, we get a -3. When you put a 2, that gives us a -5. So we plot those. Oops. I went from a -1 to a -1. That's a +1. 0, -1, 1, -3, and 2, -5. So you kind of see the pattern already.
Yeah.
And then you just kind of make your line and extend it. So the domain, you go from left to right. So when you hit the left side, you hit an arrow, and then on the right side, you also hit an arrow. So you could do all row numbers, or the same thing as -infinity to +infinity.
Okay.
Okay, and the range goes from the bottom. So what's the lowest? What do you hit? On the bottom. What's the, you hit it what?
-infinity.
And to the positive.
Positive.
Very good.
Okay.
So negative to positive, which is the same thing as all row numbers.
Oh, so they're both. Oh, okay.
Which is okay, because they have arrows in both ends. Okay, our next one is determine the x and y intercepts. That means where does it cross the x-axis and y-axis, if any. Also determine if graph represents a function. So x-intercept crosses the x-axis is only 1 point, and then you name it.
-1.
0, -1, or -1. The y-intercept, I'm sorry, I wrote it backwards. -1, 0, because it has to be the x value. I was so focused on going to the y-intercept that I lost track. So the y-intercept, where it crosses the y-axis, Now that is a value at -2 or -2. So is this a function? If you do a vertical line test, does it pass right here?
It does pass.
Doesn't pass, right? It fails right there, so it's not a function. It fails the vertical line test. Right here, the x repeats so many times, it's not valid. So go to number 4. So again, x-intercept where it crosses the x-axis, I have 1, and then I have another one. So the x-intercept will be at -5, and another one at 3. So you could do -5, comma 3. Y-intercept is only 1, at 1.
You said +3?
Yes, ma'am.
Okay.
+3. Is this a function?
Yes.
Yes, good. This line continues. It actually continues like a little angle, so
Okay.
you could do a vertical line test and it always passes.
It was passes.
I'm going to move the paper over here.
Oh.
Okay. Number 5, draw a function that represents the given real-world model, sort of more or less an idea. This represents the height, and I can see that this is t, and in our problem, it looks like they're talking about years. So the height of an average human, like normal, the first 12 years of their life. So when they're born, they're at a certain height, right? They're not at 0. When they're actually born, they're somewhere here, and they're supposed to kind of gradually just kind of grow. We don't know the rest of it, but at least around 12 years of age, that's what should happen, more or less.
Okay.
Okay, B, the volume of the air in your lungs over the course of an easy school day. Just in a normal, time, you always have air in your lungs. And so this is the volume versus the time. So as time passes. So you have air, in, you go out, you go in. And this is again throughout the school day. My little graph is a little off, but it's okay. You get the idea.
Yes.
On the back side. Okay, in this next section it says use the graph of f of x to find each indicated function value. So inside the parentheses are the x values, just like indicated there. So when you're giving your x, what you're trying to do is trying to find your y. So look at your diagram. Find when x is -3, what is your y?
-2.
Right, -2. Okay, same thing here. If your x is 1, you're trying to find y.
-2.
Right.
Okay.
Okay, so it was right. The first one, -3, you went down. At 1, you found the graph, you went down. And when x is -7, 3, 4, 5, 6, 7. Way over here, find your graph. Where does it go?
-4.
Right.
Okay.
Okay, so the next one, it says use the graph to the right to determine the domain and range. Again, domain are your x values. So you go from left to right, and then your y value from the bottom up.
Okay.
So you start from the left. What is your starting point? What is your x value that your graph began?
-4.
No, that's the y value,
Is it this way?
because domain is x. So you go from left. If you look at the pencil, where does it hit? The first graph, the first piece of your graph hits there at what x value?
Oh, okay. -7.
So this will be at -7. Is that an open circle or closed circle?
It'll be closed.
Closed, you put the little,
So bracket.
and it extends all the way. You keep going. In my graph, there's an arrow. What does that tell you? When you hit an arrow at the end. It's gonna
Positive infinity?
Right, because it's going to keep going and going. So this will be positive infinity,
Parentheses.
parentheses. All right, range is from the bottom up. So what is your lowest y value?
My lowest one would be this one.
Of your graph. So you go from the bottom up. So if you look at my graph here, I'm going up, and I finally hit a piece of
This
the
one.
graph. What's my y value that I used?
-4.
Right, it's at -4. And that is also a closed circle.
Yes.
And then if I continue my graph,
highest one is this one. So
Yeah, what's the highest? It's a
positive infinity
positive infinity.
in parentheses.
Next one, 11 and 12. Determine whether, excuse me, determine whether each relation defines a function of x. Basically, is it a function, yes or no?
Is it plotted?
You
Okay.
can plot or look for the x values. And what are we looking for? If the x values repeat. So do they?
No, they do not.
So I see one though. See how one
Oh,
goes to
one,
4 and
yeah.
one goes to 9? So this is not a function because the x
Repeat.
repeats. Okay, 12.
Okay.
You could solve it, but a good little trick is if your y value is a 1 and your x value is a 1, that is a linear function for this one because it's in a standard form of equation. So this is yes, but you could solve for y if needed. But once you hit a y squared, that's definitely a no-no that, that we're looking at. Okay, next section. I'm going to move my paper, sorry. Evaluate each function at the given values of the independent variable and simplify. So again, independent is your x. We're going to simplify given the values that they want us to look for. So if down below, your independent value or your x is 7. So what you're going to do is now substitute. Right, the 7 in here. So 7 minus 1, it's a
2 minus 1, 6.
negative 1.
Negative 1, and then you do plus 1.
7 minus 8. Sorry, I think my brain was already thinking how to solve it. 7 minus 8 is a negative 1. But the absolute value of a negative, since they're talking about distance, it will come positive. So your final answer is a 2. So whenever x was a 7 to this function, my y value is a 2. Okay, let's try this next one. We're going to put it a negative x in replace of each one. I know, I'm going fast, right? Usually I don't do this. Okay. So let's do the parentheses with the power. So negative x squared times the negative x squared will give you back a...
Positive? So positive x squared.
And then the negative times the negative is also positive.
Positive. So plus 5x.
Yep, that's it.
Okay, nice.
Okay, and our next section, 15, yes. So now we're going to add in an x minus 1 into the equation itself.
Okay.
So that will give you distributive property right there.
Yes.
So it gives you negative 2x, and a negative times the negative is a positive. Okay, and combine like terms. I think you beat me, right?
I think so.
So you could either write it this way, or you could switch it around, negative 2x plus 9. Either one is correct. As long as you maintain the negative goes with the negative x. Positive, positive. Okay. On the back side. Okay. Look at this, we're almost done. Evaluate each piecewise function. Piecewise, little tiny pieces, given values for the independent variable. Again, they're giving you the x values for each one when they're telling you about the independent. So you have 2 of these. And how do you know which one to use? Depending on what it's asking for. So here, you want all the x's that are less than 1, then you use this expression. If the x is between 1 and 3, you use this one. If the x value is greater than 3, then you use this expression here. Okay, so negative 5, does it go with the first, second, or the third?
Negative 5, the first.
Yes, we're going to go with the first one because it is less than
Positive.
1. So we're going to substitute that in there. So if my x value is negative 5, I'm going to get the absolute value of negative 5 plus 2.
Negative 3.
Negative 3, right? And the absolute value of a negative 3 always results in a positive
3. Okay.
Good. Okay, B. We have the x value of 3. Where does that fall into? The first, the second, or the third?
It's got to be less than right?
Is 3 less than 1?
3 is more than 1.
So does it fall between 1 and 3? Or is that value greater than 3?
This value is greater than that one. Less than, right? So it would be this one.
Which one? Number 1, 2, or 3? We're looking at 3. Does it fall? Is the value of 3 between 1 and 3? Or is 3 greater than 3?
3 is not greater than 3.
Right? So
Yeah.
it falls in number 2.
Number 2.
Okay.
So then you just plug it in.
Mm-hmm. So f of 3, it says 7. So no matter what, your y value is always going to be 7.
Oh, so you don't really do anything?
Because you can't substitute the x in there. There's no
Okay.
x value to put.
7.
Because all of the y values, no matter what x value, is always going to be y.
Okay.
Okay, number 7. Okay, again, we're looking for x. X is negative 1. So is x less than 0 or x greater than or equal to 0? Where does it fall in? Number 1 or number 2?
Is negative 1 greater than 0, you asked?
Yes, so you have to find out, is negative 1 greater than or equal to 0, or is negative 1
It's
less
less
than?
than.
Okay,
Yeah,
good. So we're going to use the first one. So we're going to use the first one. So if f is negative 1, you're going to get negative 1 squared minus 10.
Oh, okay. Got it. Minus 10.
Okay, so negative 1 times the negative 1 becomes a positive. Good. There you go. Okay, and the second one, 5. Is 5 less than 0, or is 5 greater than or equal to 0?
5 is greater than
So
0.
we're going to use the second one. Okay, so we take 5 squared, which is 25. You add 1 to it, so we're going to get the square root of 26. So, graph each piecewise function and determine the function's domain and range. So we're going to graph both of these. So our first equation, you want x values that are less than or equal to 0. So we're going to make a little table to kind of help us out. We always start off with a 0. So we're going to do 2 tables. Okay. Give me a number that's less than or equal to 0.
Oh, it's less than or equal to 0, negative 1.
Okay, and then just kind of pick a couple of them, and you know this is going to keep going, and what you're going to do, you're going to substitute into the expression that's given there. So you're going to have 0 plus 3, negative 1 plus 3, negative 2 plus 3, and so forth. It's up to you if you want to continue or not plotting more points. Okay, so when you once you do that, you're going to get your value. And then this one will be a 2, this is a 1, and 0, and so forth.
Okay.
Okay, so I get, now plot those points. So 0, 1, 2, 3, and that is a closed circle. How do I know that? Because it has a line underneath. So at 0, it is worth a value. Then negative 1, 2. Why am I off here? I plot at negative 3. It's supposed to be at positive 3. Look at that. I have a positive 3 right there.
Oh, no wonder.
Yes,
Yeah,
I know.
was
It's
like,
off. So I
It goes
get
up here.
negative 2, 1.
Okay.
And it continues that pattern. So we're going to continue it this way. And
3.
I'm going to put a little arrow there. Okay, our next one.
Oops.
So we're going to look for values that are greater than 0. So 1, 2, 3. Again, you could stop at any point. Use your expression. 3 minus x squared. Anytime it has something like this, I like to write it out first and then substitute the numbers in there. Okay, so I'm left with a 3. This is a 1, so that's a 2. This is a 4, that gives you a negative 1. This is a 9. That gives you -6. So plot those. So 0, 3, that one is an open circle here. Even though I draw an open circle, the closed circle overrides it. So then I would do 1, 2, 2, -1, 3, -6. And if I were to continue this, the pattern would just extend itself that way down here. And there's our graph. So our domain, our x's, you go from left to right. And our range, or y's, you go from the bottom up. So from left to right, what is the first thing you hit?
Negative infinity.
Negative infinity, very good. All the way to, keep going.
All the way to,
What do you hit? So here, and then it goes on.
this one. B.
No, right here. So you go from, remember your domain is from left
Okay.
to right.
Left
But
to
what do
right.
you hit?
Negative infinity.
No, it's going in the right direction. So that'd be your positive.
Positive.
Even though the arrow is going down, you're still going to the right, and you're continuing going right, which is positive infinity. Or you can do all row
And if
numbers.
it goes like up, but it's to the left, that would be negative infinity.
You got it.
Okay.
Good job. Range is from the bottom up. What's the
Okay.
lowest? What do you hit?
Because I haven't plotted it yet.
Oh,
1 second. 2, 3, 0. What's my lowest? You said? The this one, right?
No, the lowest part of your graph. Again, you go from the bottom all the way to the top. What do you hit first?
This one.
What is that?
Positive infinity.
No, it's you go bottom is a negative.
Okay.
When you go up, it's positive. So
So
down is
negative.
negative. So you
Okay,
hit
so
negative,
negative infinity.
and it goes all the way to the top. And you do stop at what point?
Which
It's the
would be
highest.
3.
Or again, you want all the y values that are less than or equal to 3. All of these y values are smaller.
Okay, and it's bracketed because it's closed. Okay.